about divide and conquer approach. Okay, so the contents are introduction to divide and conquer, then we'll see general method for divide and conquer, analysis of divide and conquer approach, solving the divide and conquer approach with the help of an example, and finally we'll see what are different examples of divide and conquer we have. Okay, so in introduction to divide and conquer approach, so what is the divide and conquer approach means? So in design analysis of algorithm, we have many different design strategies, okay, to solve a problem, such as greedy approach, dynamic programming, backtracking, and branch and bound. So divide and conquer is also one of the strategy to solve a computational we can say problem. Okay, so in divide and conquer approach, basically we have a problem. That problem is divided into we are dividing that problem into small sub problems, and these sub problems are solved independently and then combined to get the solution for the main problem. Okay, so this is how the divide and conquer approach works. So the step would be divide, conquer, and combine. So these are the three steps that divide and conquer approach have. Okay, so moving to the next, let's see this example. Okay, so here you can see I have a problem P. You can see I have a problem P. Okay, that problem P is of size n. Suppose we have this problem P. Okay, this problem P is of size n. Okay, and we are dividing this problem P into k sub problems. You can see there are k sub problems for this P, and these sub problems are recursively solved, independently solved, and we have the solution for the each respective sub problem. Suppose S1 for P1, S2 for P2, S3 for P3, and then similarly Sk for Pk. So we have different solutions, and then finally we are combining these solutions to to get the solution for the main problem P. So this is our final solution is. Okay, so this is called the divide and conquer approach. So moving to the next. Now, so just remember that if the problem is if the subproblem is also large, then divide the subproblem also. Okay, we are again dividing the subproblems into to make it a small problem. Okay, so in divide and conquer, we recursively follows the steps to solve the given problem. So what is the note point about divide and conquer? So these sub problems will also be the same as of the original problem. Okay, suppose we have a problem P and we are dividing that problem into small sub problems. So it is not the case that the sub problems will be of different type or different problem. Okay, so this is will have the same problem as the original problem. So for example, suppose we have a problem to sort the elements of an array. So we are dividing that array. We are dividing that problem into small sub problems. Okay, and this sub problem will also be to sort. Okay, this is the meaning of this. The sub problem will also be the same as the original problem. Okay, so next is there has to be some method to combine the solutions obtained from the sub problem. Okay, this means that so we have the divide, then we combine. Okay, so for combining the solution, we must have some method. We must have some algorithms to combine. If we are not able to combine that solutions, so that means we can't apply divide and conquer approach. So we must see that if a problem P is there, if we are able to divide that problem, then we must able to solve that. We must able to combine that problem also. This is the meaning of divide and conquer. Okay, so let's have the general method for divide and conquer approach. Okay, suppose we are defining a function that is called divide and conquer P. If P is small, suppose our problem is very small, so but we can directly solve that problem. Okay, so we are solving that problem P, very simple. So if we have if P is our small problem, so directly solve. We are directly solving that problem P. Okay, that means we must have a solution for our small problem. Okay, we must define that. Next, if our problem is very large, okay, we have a very big problem, so we need to divide that problem. So I am dividing that P into several. You can see I have divided the P into k we can say sub problems. and then we are applying the divide and conquer approach on each and every sub problems. You can see we are again calling that divide and conquer approach. Okay, we are simply dividing into sub problems until we get the small problem. Okay, and then finally we will combine the solution of each and every sub problems to get the solution for the main problem. So this is how the divide and conquer approach works. We are recursively calling the divide and conquer. Okay, so to get the solution. Okay, I think it's clear up to here. So let's next move to analysis of divide and conquer approach. So we have a problem P, okay, of size suppose n, and let's Tn be the time complexity for this problem. Okay, so we can write this as, so here you can see I have written suppose a problem, we have a problem of size n, I am dividing that problem into two sub problems each of size n by 2. That means I am dividing this problem into size n by 2. Then after suppose this n by 2 sub problem is done, then finally I need to combine this. Okay, I need to combine this what we say sub problems to get the solution for the main problem. So the combining cost that we are taking, I am taking as a function of f of n. So listen here, so here f of n is the function for combining these two sub problems. Okay, now that means we can write it as 2t n by 2. Okay, 2t n by 2. So here this means we have two sub problems each of size n by 2, and f of n is the cost for combining the solution. Okay, so what is the general formula for finding the for finding the time complexity if we are applying this divide and conquer approach means? So here you can write, so here it will be like this. So we have this a times number of sub problems each of size n by 2, n by b. A is your number of sub problems, or this is the size. Okay, it is the number and it is the size, and this we are taking as the cost function for combining. Okay, this is a general formula we can say for finding the time complexity, where a, b are the constant. Okay, so next let's have one example to solve this divide and conquer approach. Okay, so let's take an example where we have this following. Yeah, we have this 2t n by 2 plus n. So here n is the cost for combining. Okay, so here, given that if n is 1, the time complexity for solving that is 1. So this is our, we can say, small problem. The condition here that is written, this one is our stopping condition, or we can say small problem condition. Okay, so this is, we need to solve this. Okay, we need to solve this. Okay, so let's apply the substitution method. So listen how we are going to solve this. Okay, so we have this we have 2t n by 2 plus n. Okay, again I can write this as 2. Again this will call itself, so this is sub problem. Again we need to divide until we reach the 1. So again it will divide. So how it will be look like? It will 2t, again this can be written as, okay, 2t n by 2 square, okay, plus n by 2 plus n. That means this t n by 2, okay, this is our tn. This t n by 2 again divided into small sub problems. Each of the number is 2, size will be n by 4. So we can write it as n by 2 square, and the cost will be n by 2. Again this is the main, we got the sub problem. Again we can divide. So how it will look like? So we can write it as 2 square t n by 2 square, okay, plus n plus n. Okay, this is how we are simplifying this equation. Now again we can write this as how? 2 square, okay, 2t n by 2 cube. Okay, so if we have n, so we are that means size becomes n by 2. If a number is n by 2 square, the size will become n by 2 square divided by 2. It will become n by 2 cube, and plus n by what? 2 square, and we have plus n, and we have plus n. Okay, so next, so how we can write this equation as? So let's take we are repeating this as up to k times. After k times we are able to reach to the small problems condition, that is n equal to 1. So this is so we are repeating to k times me, we can write it as, so how we can, let's simplify first. Okay, let's simplify this. Before this, let's simplify this. Okay, so let's have this erase first of all this one. Okay, we'll first simplify, then we'll take up to k times. Okay, so listen, so how we can write, it will become 2 cube. Okay, so it will become, just erase this. Okay, so let's, okay, so yeah, so we can write it as 2 cube. Okay, and then t, how we can write this is that is n by 2 cube. Okay, plus n plus n plus n. Okay, so this is how we got. So if you repeat this up to k times, that means after k times we are able to reach to the small problem condition, that is n equal to 1. So that means we can write it as 2 power k t n by 2 power k plus this is how many times this n cost will be added, it will be added up to k times, k into n. So listen here, so here I am writing on the you can see now the condition is if this n by 2 power k will be equal to 1. Yes, we need to reach to this condition, that is t of 1. Okay, so this n of n by t this 2 power k is 1. So how we can write this, this is as, so we can write if you solve this equation, so what we will get here. Okay, so let's find the value of k here. So if you solve this, you will get the value of as log n. Yes, this 2 power k will go here, and if you take log both sides, we will get k equal to log n. So that means the value of k is log n. So let's replace the value of k. Okay, I am going to replace the value of k here. So how this it will look, the question will become 2 power this log n. Okay, t that is, it is our n, and this is the n by 2 power k, it is 1 now. So this is our 1 plus k is log n, so n, so it will become n log n. Okay, now we know, so it is 1 actually. Okay, this is t of 1, it is not, it is t of 1. So it will become 1. So what is the, if you solve this, base 2, so what we will get, you will get n plus n log n as the simplified answer. Okay, so which is greater among these two, which factor is greater, n log n is greater, so we can say big of n log n is the answer. So remember, so if you have if we are dividing a problem into 2 sub problems, each of size n by 2, and the cost is n, so the time complexity will be n log n. Okay, so this is how we are using the substitution method, so we get the answer as n log n. Okay, it is I think it's easy, you can solve this. Okay, so for practice you can have this question. So we have given a problem P of size n, it is divided into 8 sub problems, each of size n by 2, and the cost for combining the sub problem is n square. So given this, find the time complexity if you are using divide and conquer approach, and for this given if p is equal to 1, so t of 1 is equal to 1, use substitution method. Okay, so you can solve this question and you will get the answer. Okay, let's have the what are different various examples of divide and conquer we have. So we have binary search algorithm where we use the divide and conquer approach. We have quick sort algorithm, we are using the divide and conquer approach. Binary sort, merge sort. Then we have finding the maximum and minimum element, power of an element. Okay, and find and Strassen's matrix multiplication, and lastly to find the convex cell. So these all are the examples of divide and conquer approach where we use this strategy. Okay, so thank you so much.